language session 7.
In the 7th session, we are going to discuss about cardinal number problems. In this session, we are going to see 5 problems. Just have a glance on these problems. First, some deals with the cardinal number regarding different sums, and the second sum is regarding difference and subset, and third sum it deals with the subset, and fourth as well as fifth, these sums also deals with cardinal numbers. So let's see the first problem. Here it is given there are two sets A and B, and the clue they have given us is like this: n of B difference A is equal to 2 into n of A difference B. That is equal to 4 into n of A intersection B. And then they are giving us one more clue, that is n of A union B is equal to 14, and the question is find n of P of A. Right. So here they are giving us a clue. Let us use the clue first. The clue says n of B difference A is equal to 2 into n of A difference B is equal to 4 into n of A intersection B. Right. Let us try to find what is n of B difference A and n of A difference B. For that, let us think this n of A intersection B as K. So let us consider n of A intersection B as K. If n of A intersection B is considered as K, then n of B difference A is equal to 2 into n of A difference B is equal to 4K. Right. Now, if you equate this equation, the first clue says n of B difference A is equal to 4K. So we got answer for n of B difference A in terms of K. So n of B difference A is equal to 4K. The next clue, it states 2 into n of A difference B is equal to 4K. Let us take this clue also. So 2 into n of A difference B is equal to 4K. When the multiplication, if the multiplication 2 goes, that set will become division. So our answer will be n of A difference B is equal to 2K. So we got clues for all the three terms, for n of B difference A, for 2 into n of A difference B, as well as for n of A intersection B. For all these three, we have clue in our hands in terms of K. So now let us apply this clue. Before that, if you see this A difference B or B difference A, A intersection B, if you see these three things, these three collectively gives us A union B, because this is only B, this is only A, and this is common to A and B. So it gives us collectively A union B. If you see this diagram, you can understand it. Right. So this is A difference B, that is only A, this one. This is B difference A, that is only B. After that, the common one, that is A intersection B. So the terms here is this. Right. From this, if you see, you can come to your conclusion. Since this A difference B or B difference A and A intersection B, whatever it may be, these three are disjoint. As you know, if A and B are two disjoint sets, then we can say n of A union B as n of A plus n of B. So here, this is totally A union B. This is totally A union B. So n of A union B can be written as, according to this formula, as n of A difference B plus n of A intersection B plus n of B difference A. Since these three sets are disjoint, so we have a clue like this. Now let us apply the result what we have obtained. The first one is n of A difference B, that is 2K. So instead of this, we can write 2K. Moreover, they have given us n of A union B as 14, so we can write for n of A union B as 14 for this 2k, for this n of A intersection B is k, and for this n of B difference A, we can write 4k. Now let us substitute all this clue. Here, if you see, the result is 14 is equal to 7k. So the k will be 14 by 7, that is equal to 2. So we got answer for k value. Since we know the value of k, now it is very easy for us to find the number of elements in A difference B or B difference A or in A intersection B, since we know the value of k. If they are asking you to find n of B difference A, it is very simple. 4 into 2, that will be equal to 8. So n of B difference A is equal to 8. Now let us go to the problem. Here they are asking us to find n of P of A. Before finding n of P of A, first of all, we must know what is n of A. If we know n of A, then we can proceed for n of P of A. How to find n of A? Now let's come to this diagram. This is our A. This is our A. This A is nothing but A difference B union A intersection B. Combination of these two disjoint sets, this A difference B set and A intersection B set. If we unite these two sets, we'll get set A. So we can write, since A and B are this set, this A difference B set and this A intersection B set, these two sets are disjoint, we can apply the formula like this. If two sets are disjoint, then n of A union B will be equal to n of A plus n of B. So since these two sets are disjoint, we can apply the formula. This n of A, the total number of elements in the set A, will be equal to number of element in A difference B plus number of element in A intersection B. So we have the next clue. N of A is equal to n of A difference B plus n of A intersection B. What is n of A difference B? That is 2k. N of A intersection B is k. If we add it, we'll get the answer as 3k. Since k value is 2, 3 into 2 is equal to 6. So now we know how many elements present in A set. So it is very easy for us to find n of P of A, because formula for n of P of A is 2 power n. The n value is 6. Number of elements in the set A is 6. So n of P of A is equal to 2 power 6. That is equal to 64. So we got answer for this problem. So it's very simple. Now let us go to the next problem. Here the problem goes like this. Capital X is a set. It has elements from 1 to 10. And there is another one set, that is capital A. It is 1, 2, 3, 4, 5. Moreover, they are giving us a clue, that is A difference B is equal to 4. But the question is, if A difference B is 4, then what is B? That's the question. So if you read the question, you can understand it very easily. If capital X is equal to 1, 2, 3, to 10, and if set A is equal to 1, 2, 3, 4, 5, find the number of sets, that is B, which is subset of X, such that A difference B is equal to 4. So we have to find set B, which is subset to this X, such that we must get the answer as A difference B is equal to 4. Right. Now let us do one thing. First, let us use the clue. The clue is A difference B is equal to 4. What do you mean by A difference B? A is a known set and B is unknown set. So A difference B is nothing but A is 1, 2, 3, 4, 5. Difference B, this set we have to find. And A difference B is given as 4. Right. Now, what do you mean by A difference B? A difference B is nothing but only A. A difference B means only A. The meaning is this result, it talks about this result. Only A or A difference B means the elements present only in A but not in B. That's what your result. So simply we can say the result is 4. So this 4 exists only in A and it does not exist in B. So in B, we will not get this answer 4. But the remaining elements, that 1, 2, 3 and 5, will be in B also, because A difference B is equal to 4. It says this is the only element which is in A alone. So 1, 2, 3 and 5 are in B also. Right. So our B, the primary set, is 1, 2, 3, 5. Now you can, if you want to find A difference B, you can see. Just see this A set and just see this B set and find A difference B. A difference B means comparing with these two elements, that element must present only in A. So the only element is, that is 4. So this is correct. So our B set is 1, 2, 3, 5. That's good. This is it present in X? Because that B set should be a subset of X. Is it present in present in X? Yes, it present in X. So it is a subset to the set capital X. If we compare these two sets, this 1, 2, 3, 5 and 1 to 10, the remaining elements are 6, 7, 8, 9, 10. These elements present in the set capital X again. Shall we include this with this B or not? Yes, we can include it. Even if you include and number 6, that will be 1, 2, 3, 5, 6. And after that, if you try to find A difference B, again you will get the same answer. Because whenever we find A difference B, we used to see what are the common elements for A set and B set, and we used to put tick in the A set or in the set which is in the front. So if our B set is 1, 2, 3, 5 and 6, if we try to find a common for 1, 2, 3, 4, 5 and 1, 2, 3, 5, 6, the common element will be only 1, 2, 3 and 5. That will be ticked and the answer will be 4 again. So even if I include number 6, there will be no change in the A difference B value. Even if I add 7 to this, that is 1, 2, 3, 5 and 7, again I will get the same answer. So whatever I want, I can include it, but my answer will not change. I'll get the same answer as 4. So these elements can be added. How can we add it? If I don't add anything, I'll get the same result. If I add 6 alone, I'll get the same answer. If I add 7 alone, I'll get the same answer. Or if I add 6 and 7, I'll get the same answer. If I add 6, 7, 8 like that also, I'll get the same answer. Even I can include all these terms. So what are the ways to add? Nothing to add, that is empty. Single elements we can add, or double elements we can add, or triple element, or 4 elements, or all the 5 elements. So if you see this with this set, you can come to the conclusion these are nothing but subset to this. So these much options we have. To get this set alone, we have to include this. You can then after that, you can, if you want, you can add 6 or 7, like that you can add it. So there are 1, 2, like that it goes on. These much options are there to be added. So if we find number of subsets to this set, then that many sets we can frame for B. So number of subsets to find to that set 6, 7, 8, 9, 10. If you want to find the number of elements in the set, there are 5, and the number of subsets will be 2 to the power 5. So the number of ways is 32. So we can form 32 subsets, 32 sets for B, and we will get the answer as A difference B is equal to 4. That's good. So this is a very simple sum, but anyhow, think once more and confirm in your mind. Right, now let's go to the next sum. It says there are 2 sets. First set has m elements and the second set has k elements. After that, they are stating the total number of subsets of the first set is 112 more than that of the second set. So first set has more subsets, second set has less subsets. then ultimately number of elements in the first set will be more than the number of elements in the second set. So let us take the first clue. The question is two sets have m and k elements. Total number of subsets of the first set is 112 more than that of the second set. Find the value of m and k. So it's easy. The first clue, it gives the problem states that number of subsets in the first set is more. So clearly the first set has more number of elements. So m is greater than k. Then automatically the number of subsets is 2 power m for the first set and 2 power k for the second set. Since m is greater, 2 power m will be greater. So 2 power m subsets are there for the first set and 2 power k subsets are there for the second set. And it states the first set has 112 more subsets. 112 more subsets. So if we subtract it, that is, if we subtract 2 power m minus 2 power k, our answer will be 112. Since k is smaller, we can take 2 power k commonly outside. If we take 2 power k commonly outside, the result will be 2 power m minus k minus 1 is equal to 112. Right. Now let us try to bring this 112 in the format of 2 to the powers. If we try to bring it, we'll get the answer as 2 power k into 2 power m minus k minus 1 is equal to 2 power 4 into 7. That is 16 into 7. Right. Now here the main work comes. If you see this and this, these two will be equal to one another. And these two will be equal to one another. You may wonder why. Because while simplifying this 112, we'll get 2 into 2 into 2 into 2. Further, we'll not get again 2. So, at the maximum time to get 2 is 4. So, it is 2 power 4 into 7. That is 16 into 7. So, these two can be equated because further we'll not get any 2 to the power in this side. Moreover, if you see this is minus 1. It is 2 to the power. So 2 to the power will give you only even number. Even number minus 1 will give us only odd number. So this odd number will be equal to this odd number. So these two can be equated. So these two can be equated and these two can be equated. But this is not general law. For this equation, it works. So if we equate it, we'll get 2 power k is equal to 2 power 4. So k will be equal to 4. And let's go to the next part, that is 2 power m minus k minus 1 is equal to 7. If minus 1 goes, that's it will become as plus 1. So 2 power m minus k will be equal to 8. 8 can be written as 2 to the power 3. So if we equate the powers, so m minus k will be equal to 3. Right. Since k is equal to 4, let us try to substitute k as 4. Then m minus 4 is equal to 3 and m is equal to 7. So we got answer for m and 7. So m is equal to 7 and k is equal to 4. So it's also very simple sum. Now let's go to the next problem. The problem states like this. If n of p of a is equal to 1024 and if n of a union b is equal to 15, n of p of b is equal to 32, find n of a intersection b. Okay, whatever it may be, the clue deals with the power set. But the question is not with power set. So let us do one thing. Let us try to come out of this power set. Let us take the first clue. It is given n of p of a is equal to 1024. So this 1024 can be written as 2 to the power 10. This is in the form 2 power n. So this power 10 is nothing but number of elements in the set A. So we can find n of A. So it gives us n of A is equal to 10. So from the first clue, we got number of elements in the set A. Similarly, let us use this second clue, that is n of p of b. That is n of p of b is equal to 32. 32 can be written as 2 to the power 5. So from here we can come to the conclusion number of elements in the set B will be equal to 5. So n of B is equal to 5. So n of A is 10 and n of B is 10. Further we have the clue n of A union B as 15. So let us apply the formula of n of A union B. N of A union B is nothing but n of A plus n of B minus n of A intersection B. And that n of A union B value is given as 15. Right. Now for n of A we can write 10. For n of B we can write 5. So 10 plus 5 minus n of A intersection B is equal to 15. So 10 plus 5 is 15. 15 minus 15 will give us 0, and if the minus goes that side it will become as plus. So n of A intersection B is nothing but 15 minus 15, that is 0. So number of elements common to A and B is 0. This is also very simple one. And let's see one more sum. Here n of A intersection B is equal to 3 and n of A union B is equal to 10. Then find n of P of A delta B. So the clue is regarding simple cardinal numbers, but the question is about power set. Whatever it may be, let us try to understand first of all what is A delta B. If we know A delta B, then we can proceed further. Right. What do you mean by A delta B? A delta B is nothing but A difference B union B difference A. A difference B union B difference A. That is, only A is united with only B. A difference B means only A. B difference A means only B. If you see the diagram, you can understand it very easily. Right. See, this is our only A part. Only A part. That is A difference B. And B difference A is nothing but only B part. This is what our only B part. You know well. Right. So A delta B is nothing but combination of these two. This and this. It is combination of, or it is union of these two disjoint sets. So A delta B is nothing but combination of these two sets. Since this set and this set are disjoint, we can write n of A delta B is nothing but n of A difference B plus n of B difference C. So n of A delta B is n of A difference B plus n of B difference C. Right. Now we know formula for n of A difference B. N of A difference B is nothing but n of A minus n of A intersection B. If you see here, you can understand it. This is A set. So number of elements in A difference B is nothing but n of A, this total, minus this n of A intersection B. So we have formula for it. N of A difference B is nothing but n of A minus n of A intersection B. The same way for n of B difference A, we have n of B minus n of A intersection B. Right. Now if we simplify it, we'll get n of A plus n of B minus n of A intersection B. Then further we can add this minus n of A intersection B. So our simplification gives like this. Now if you see, these three terms is nothing but n of A union B. It gives us n of A union B. So we can write this as n of A union B for this minus n of A intersection B. Right. Now just come to the clue. N of A union B is 10. We can write this as 10. And n of A intersection B is 3. And we can write for this as 3. So the result will be equal to 7. Now we know how many elements are in A delta B. If you know how many elements are in A delta B or in a set, then its power set will be nothing but 2 to the power n. So the result will be n of P of A delta B will be equal to 2 to the power 7. So the answer is 128. So this is also very simple sum.